Good morning, guys. So today we're going to do a page in your notebook. So you're going to watch this video and fill in your notebook as we go along, just like I was there. So make sure that you're on focus question 4. In what state of matter do most elements exist? And then you're going to need 3 colored pencils or crayons. Okay, so if you need to stop the video and go get those things, go ahead, and then you can restart it. I have to keep going though, otherwise my video will be too long and it'll take forever to upload. All right, so state of matter. So we know that there are 3 states of matter. So we're going to come down here to the explanation first. So we've got solids and liquid and gas. Okay. All right, so a solid, if it was in a container, the particles would stack right on top of each other and be very close to each other. Right? And if I had a container and I poured a liquid into it, it's going to go ahead and like fill up the bottom part of that container, right? It's going to take the shape of the container that it's in at the bottom. And then the gas, if I were to put it into that same container, is going to spread out and fill up the whole container. And if there wasn't a lid on the container, then it would start to escape, right, out into the air. Okay. All right, so a solid then, we say, has a definite shape. Imagine a cube or a rock or something like that. Whereas a liquid takes the shape of its container. So if I took the same liquid and poured it into a really tall column, it's going to do this, right? So it's still going to be the same amount of liquid, but it's going to take the shape of its container. And then a gas is just going to fill whatever space we allow for it. So it has no definite shape. It's going to just fill up whatever space. If there's a lid on it, it'll like inflate a balloon, right? Or if the container's not on it, like imagine if you spray cologne, then it's going to fill the room up, right? Or maybe if you fart, same thing. All right, so as far as shape, solids have a definite shape, liquids take the shape of whatever container, and gases are just going to fill up their space. As far as the amount or the volume, solids have a definite volume. They have a very specific amount. I could measure length times width times height, or I could put it into a container and see how much water overflows. Kind of like when you get into the bathtub, right? The amount of water that rises up is how much volume you are. The liquid also has a definite volume. Like I said before, if I have 100 milliliters of liquid in this container, and then I pour it into this container, it's the same amount. It's going to take up a different shape because the container is a different shape, but it's still going to be the same volume or the same amount. Whereas a gas has no definite volume. It's going to just fill up and take up as much space as it can. So no definite shape, no definite volume, fills up whatever space. So the solids then have a very minimal space between them. So there's almost no space between the particles, and they move just a tiny bit, maybe just vibrate in their position. Liquids are going to have more space, and they're going to slide past each other. And remember, if I'm talking too fast or writing too fast, just stop the video and then rewrite. I just can't stop my video, otherwise it'll take too long to load. And then gases have a lot of space between them. And they are going to bounce off each other and move all around, bounce off the walls of the container. That's how a tire stays inflated or a balloon stays inflated. So they're going to just be bouncing around in lots of space between them. Okay? All right, so those are our 3 states of matter. Yes, I know that sometimes we hear about something called plasma, blah, blah, blah. That's not what we're going to worry about as far as 8th grade. Okay. All right. So we're going to go ahead. We're going to start with thinking about if we have these 3 states of matter on the table. We talked a couple days ago about how about 2/3 of the table are all metals, right? So which which state of matter do you think would be the most popular then? How do we see most metals? As solids, right? So a lot of the table is going to be solids. We did learn about some of the gases. We said group 18, this column 18, were what were called the noble gases. So we know some gases. We know oxygen is a gas. We know hydrogen is a gas. So you're familiar already with some of the gases. And then liquids, probably not so much. Okay, so liquids is actually the one we're going to start with. Okay, so I'm going to use green. I'm going to set up my key. So green is going to stand for liquid. So at room temperature, there are only 2 elements on the whole table that are going to be liquids. The first one is a metal. So if you find number 80, mercury. Okay, mercury used to be in thermometers. It's that silverish liquidy metal. So mercury is one of them. So mercury, which is a metal. And the other one is a non-metal. And that one is bromine. Okay, so those are the only 2 on the whole table that are liquids. Okay. All right, now we're going to do our gases. So I'm going to make pink my gases. So some that we really are already familiar with, we know hydrogen, number 1, is a gas. And remember, you can stop the table if I'm going too fast. We know all the noble gases are gases. So going down group 18 here. And remember, the UUU things we're kind of just not worrying about. They're not really very common anyway. We know oxygen is a gas. Nitrogen is a gas. And then you might not have realized, but fluorine and chlorine are actually both gases. Chlorine we think about as putting in our pool. That's liquid chlorine. But chlorine is actually a gas. It's like mustard gas, which you may have learned about in social studies. So fluorine and chlorine are actually both gases at room temperature. Okay. All right. And then we are left with our solids, which you can see is like a lot of the table, okay? So iodine, which you think about as a liquid because we use it to like clean up cuts and stuff. It's that brownish liquid, but it's actually a solid. And then all of the rest of these. And I'm going to just kind of color fast like this. I expect you to color much neater. But all of these, all the transition metals except for mercury, all of these, okay, and all under here. Okay, so those are all solids. And now I want you to look at the table for me and tell me something that you think is pretty unique about group 17. So group 17, if we look here, it's the only group on the table which was called the halogens. So group 17, the halogens, is the only group with all 3 states of matter. And we can see that most of the table are solids, which makes sense because most of the table are metals, and we think of metals as being solids. We wouldn't really think of a gas as a metal, and then our only exception is mercury, which is a liquid for a gas, for a metal, excuse me. And then we have 1 liquid non-metal. Okay? All right, so I expect your table to be colored this way, and then you have a quizzes for you to complete. Okay, thanks guys.